Example 2, we're trying to find the surface area of this building. They want to cover the outside of it with paper. How much paper will be needed to cover the entire model? Anytime we're talking about covering something or painting something, or how much material would it take to make this, that's talking about surface area. So on this problem, likely what could be just given to us would be this picture. And from this picture they could say, find the surface area of this. Finding the surface area, sometimes we have considerations we have to read about. Is there a bottom part on this that we're using or not? In this case, we're going to say there is, because they don't tell us otherwise. Okay? Obviously, if we were painting something like this, we would not paint the bottom, because that would be on the ground. Make sense? Okay. So what we're doing, we're going to split this up into some different sections. So what kind of shapes do we have on this figure?
We have two triangles on each side.
Okay, we got some triangles.
We've got rectangles.
Rectangles, good. Okay, so what we're going to do, we're going to look at all of our different pieces here. We're going to find our areas, we're going to add them together. So since triangles was mentioned first, I guess we'll go ahead and look at those first here. So we're just going to find the areas of these things and then add them together. So triangles, on your reference sheet, you've got a formula for that. Triangles is 1/2 times base times height. What we need to remember on a triangle is the base and height meet each other at a right angle. So the base is kind of, we think of it being at the bottom. It doesn't have to be, because they can turn the triangle different directions. But the height is kind of like how tall our triangle is. It always meets the base at a right angle. So in this case, we might be able to think about our height is going this direction on our triangle. So the question is, if we consider this end to be a big triangle on that one red part there, what would the base of our triangle be?
12.
12, good. So our base is 12 centimeters, and what would the height of that triangle be?
20.
No?
10.
No. Okay, how'd you get 8?
On the side, there's a 20, which is the height of the whole thing. And then on the other side, there's a 12 centimeters, which is the height of the square. And you subtract that.
Good. So we've got a 12 at the bottom here. We've got a 20 as the total thing. So 20 minus 12 would be 8. And how many triangles do we have? 2. Good. So the area of our triangles would be 96 square centimeters. We're going to have quite a bit of stuff we'll be working out here, so you may want to circle that, box it in, something, so you can make sure you can find it later. That's our triangles. Besides the triangles, we have some different rectangles. So the rectangles, we've got some different sets here. We're going to have, I'm going to call the sides I'm going to call like this here. So what's the dimensions on that?
24 by 12.
24 by 12, good. And how many of those do we have? 2, good. Okay, so we're going to do 24 times 12 times 2.
76.
Okay, so 576 for those 2 rectangles. Okay, those are those 2 sides. One side we can't see right now. Okay, we've got some other rectangles here, maybe something like this in green here. Might call that the front and back. What's our dimensions with the front and back rectangles? 12 by 12. Okay, they're actually squares, aren't they? Okay, and we got 2 of those. So we might remember 12 times 12 is 144 times 2 is 288. Okay, besides that, before we forget about it, we might want to take care of the bottom rectangle. So the bottom rectangle dimensions, 24 by 12, good. Is that 288? Okay, we're not quite done yet. What have we forgotten so far, or just haven't gotten to yet?
24 by 10.
24 by 10, okay, which is what?
The 2 top parts.
Okay, good. So we're going to have rectangles on the roof part. 24 by 10, and how many of those do we have?
2.
480. Good. Okay, so once we've got that, we're going to be adding all these together here. So we're going to have 96, 576, 288, 288, and 480. We'll add all those together. Okay, 1,728 square centimeters would be our surface area. Good. Look at example 3. Again, they could just give us this picture here. And what we need to think about is on this one, kind of like that last one we looked at, the bottom part's like a cube, but we're going to have 4 sides going around plus the bottom. The top piece is not going to be there on that cube, right? And then we just have this other piece on top. So that's why in your book here they're doing 6 times 6 is 36 for one of these. And then they're multiplying that by 5 to get 180. That's all the square pieces. And then we've got the triangles. Each triangle has a base of 6, a height of 4. So that's 12 for one of these. And then we've got 4 of those triangles, so 12 times 4 is 48. And then just add those together is 228 square inches. Similar idea for the try it here. And just mentioning this problem, we're not going to work this problem out all the way, but just make sure when you do these problems you read the directions, because they can change what they're asking us to do from one problem to the next. This time we're painting this. A can of paint covers 32 square feet. How many cans of paint do we need to cover the entire front and back of the barn? Okay, all we're actually painting are the front and back here. So the sides, the roof, all that stuff we're not painting. So basically we could take, it's finding the area of this whole thing and then doubling that, which we could split that up. If you just cut across the top there, we could make a big triangle on the top and then a rectangle, and then we would have a twin of that on the back side here. Does that make sense? Key concept, just kind of recapping things. Once again, if you get a 3-dimensional figure like this and they want the surface area, just remember where A and B meet, we're not going to consider a face there. We're just doing surface area. Think of surface area again. It's what I can actually, if I picked this up and turned it around, I would be able to see all the surfaces. And all those surfaces, those areas we add together, gives us our surface area. So we don't have to cut it apart and find sides inside of this. It's just what's on the outside. We look at do you know how number 6. A stage block is being covered in carpet. Dimensions of the block are 2 feet by 3 feet by 6 feet. Every surface will need covering except for the surface touching the floor, which is 3 feet by 6 feet. How would you calculate the surface area that needs covering? Alright, so when I'm hearing about this stage block, what kind of shape are we thinking about?
Like a cube or a rectangular prism.
Rectangular prism, good. Okay, so rectangle would just be a two-dimensional figure, but if we kind of go further with that, and again, if you have a hard time to draw this out, just remember you can take a rectangle and then have another rectangle, just cross it in the corner and then just connect your corners together. Alright, so we know by what they told us the part touching the floor is 3 feet by 6 feet. So it doesn't really matter which one's the 3 or the 6, just that we have it on the bottom part there. And then we know our other dimension would be 2 feet. So since we're covering this thing, we know that's dealing with surface area. So we just need to remember we're not going to be covering the bottom of this basically. So what would be some sides that we need to find our areas of? Okay. So we have sides. I'm going to call this to be one of the sides. So dimensions there. 6 by 2, good. How many sides do we have? Okay. Besides the sides. Okay, top and bottom. Now what are we going to remember though this time?
You don't need to do the bottom.
Good. We're just doing the top on this one. Make sure we remember that. So what's the dimensions on the top?
It would be 6 by 3.
6 by 3. Good. Don't double it. We've only got the one this time. The bottom we're not doing. Okay? And then we've got what? Front and back. Good. Okay, so front and back. We'll make red here. What's our dimensions there?
3 by 2.
Good. 3 by 2. We'll double that. Would be 12. Okay. And then I'm just going to make a separate thing here showing adding those together, which would be 54. Good. So 54 square feet would be our surface area. Okay, so again, all these problems with the surface area, basically we're just breaking them apart, thinking about our different shapes that we have. Use our reference sheet if we need to for our area formulas. Find the areas and then add them together. So the solar panels on this problem, we're putting shingles on the walls so we don't have to paint here, and we're putting solar panels on the roof. So for the roof part with the solar panels, we've got a 9x5. Maybe we'll make mention here, this is our solar panels. Nine by 5 rectangle, we've got 2 of those, so that would be 90 square meters, and it's $4 per square meter, so we'll take 90 times 4, would be $360 for the solar panels. That was the relatively simple part to this problem. The next part we're going to be looking at the shingles. And this part on the front here, we're going to assume this is like a doorway, that we don't have anything there for some reason. Maybe we're going to buy some kind of a metal door or something that we don't have to mess with putting shingles on. So for the shingles, probably the easiest thing first of all would be to do these side walls. So the side walls we're going to say are 9 by 7, and we have 2 of those. So 126 square meters for the 2 sides. And then we got the front and back. I'm going to start with the back just because the whole thing would be there on the back. We don't have this cut out. So if you think about one way of doing this, we've got a triangle going across here. So on the triangle part, the total height is 10, take away 7 would be 3, would be like our height of the triangle. The base of the triangle would be 8, so 1/2 times 8 times 3, which would be 12. And then we have the that's the triangle part on the back. Then we have also the rectangle on the back. At the bottom would be 8 by 7, which would be 56. So if you think about that all together, that means the back would have an area of 68. 68, combining those two together. Does that make sense? Okay, so for the back, 68 is all that. Then the front side, we could look at 68's the whole thing, and then we're taking out that the door part. So if our door part is a rectangle, 4 times 4 is 16, and then we could take 68, which was the back part, minus the 16, would leave us with 52. And we had several other ideas suggested, so this is just a different way of doing that. We could do rectangles on the sides on the front, rectangle on the top, and a triangle. You could split it straight down, make 2 trapezoids. We've got several different ways of doing that. So that would be the front. We got the back, we got the sides. So if we add those together, so we got 126 plus 68 plus 52 is 246 square meters. This part is what we're going to do on the shingles with. So then we could do 246 times 250. And that should be $615. So we got $615 for the shingles. Way back here we had $360. So then we'll add the $615 and the $360. giving us a total cost of $975. Very good. Okay, so these are, you know, kind of a real life type situation. You know, again, you may never have seen shingles on the side of a building before, but like I said, maybe those will last longer than painting it. I don't know.